All right. So this is from problem number 22 last night. Find sine of x as a ratio. And again, what we have to do in these problems, if I want to find, first off, identify our angle. Where are we at? X is down here. So if this is my angle, which side is going to be the hypotenuse of this triangle? Okay. And 7 root 3 is the opposite of the adjacent. That's adjacent. So the opposite is going to be over here. I don't know that. That was kind of a strange thing with the delay. Try that again. There's my opposite. But I need to find out what that side is, and the only way we can do that is Pythagorean theorem. So we call it x, so x squared plus 7 root 3 squared is 14 squared. Now, some people didn't do that in this problem. What was another method that could have been done to find that third side? Anybody catch something? Well, I could, but what special triangle do we have here? Yeah. It's a 30, 60, 90, isn't it? It fits our pattern. This is 14, this is 7 root 3. I see that, it's like, oh, half of 14 is 7. If this is 7, 7 root 3, 14. It fits my 30, 60, 90 pattern. So if you know your 30, 60, 90 pattern, you're actually saving yourself a whole lot of time and work here by recognizing the pattern and finding that that third side has to be 7. So then my sine of an angle, sine of x is the opposite over the hypotenuse, which is 7 over 14, which is 1/2. And of course, the decimal, that'd be 0.5000. Well, we could also do it this way to find that third side, but it does require a little more algebra. 7 squared is 49. Root 3 squared is 3, is 196. So x squared plus 147 is 196. Subtract the 147. So x squared is 49, so x is 7. Obviously, knowing and recognizing the 30, 60, 90 triangle would make that a lot faster, wouldn't it? Nonetheless, we can set up our ratio. And because it's a special triangle, we know this angle has to be what measure? 30 degrees, yeah. All right. You weren't asked to find that, but that's okay. Find the value of h round to the nearest hundred or whole number of feet. This is one of our homework problems again. Find that length, h, right here. Well, I'm going to change the variable because h stands often for hypotenuse. I don't want to confuse it. So I'm going to change that just to x. I'll just change it to x up there. That's fine. I can call it whatever I want. I just want to get confused h with hypotenuse. So here's my angle. There's my perspective. If this is my angle, 18 is which side in this triangle? The hypotenuse. And 8x is the adjacent. And using TOA, adjacent and hypotenuse is right there. So cosine of the angle is the ratio of the adjacent over the hypotenuse. There's my equation. So we use our relationship to set up an equation. Then we solve that equation. X is in the numerator, so I don't swap. What do I do when x is in the numerator? Multiply both sides by 18. So 18 cos 27 equals x, and it sets the nearest whole number. So I put that in my calculator. 18 cosine 27. 16.03 feet to the nearest foot, that would be about 16 feet. Yeah. It's actually 16.038, etc. So round to the nearest foot, that'd be about 16 feet. Okay? Any other questions from the homework? Because there are 2 problems directly from last night's assignment. Is there anything else you'd like me to go over? All right, I'm going to switch things up a little bit. So as far as how I'm teaching this next section, how I've done in the past. Because people get very confused sometimes with the inverse functions for sine, cosine, and tangent. It's not that tough, but we're going to probably wind up using our chart in the back of the book more than our calculator for this, just because people tend to find that a little less confusing. You may use a calculator, but you have to be very careful how we do that. What we're looking at today is solving right triangles. And basically this is putting it all together. Solving a right triangle means finding all the sides and all the angles of the triangle. Finding all the information we can about it. And for the most part, we've been doing a lot of that already. We know how to find the sides, we know how to find but we don't know how to find the angles all the time. That's what we're going to learn as new today. But there's a couple different ways we can do this. Special triangles. If it's a 30, 60, 90 or 45, 45, 90, obviously use the pattern. It's very quick to solve it that way, just like we did in our first example today. I mean, I know this is 30. If I know this is 30, this must be 60. That triangle is solved because I know all the sides and all the angles, and we're able to do it using our pattern. So if it fits the pattern, use it. Second case is this. If I know one side and one acute angle, I already know it's a right angle, we use trig and triangle sum to find the missing parts. So in our previous example, if I need to solve this triangle, I've already found this side is about 16. All right? This angle is 27. Finding this angle is going to be easy. I don't have to do anything special to find that angle because I know 2 angles of my triangle are 90 and 27. So the 3 angles have to add up to 180. This is nothing new. So this angle up here must be 63 degrees. 63 plus 27 is 90, and 90 plus 90 is 180. What I haven't done is found that third side yet. And I could find that third side. I'd probably just do another trig for that. I would do sine of 27 equals this side, we'll call it y, over 18. And then 18 times sine 27 equals y, because y is opposite over hypotenuse, you need that opposite. So 18 sine 27 gives me about 8.2. And I've solved that triangle. You've used sine, cosine, just like we've been doing. Nothing new there. You've done problems like that before. We'll do them again. Very common way of solving a triangle. The third case is where it's going to be something new today. If I know 2 sides and only the right angle, so I don't know either of the acute angles, but I do know 2 sides of the triangle, first off, I can use Pythagorean theorem to find the third side of the triangle. That's not a problem. Pythagorean theorem, boom, done. But second, we're going to use trig to help us find the angles. So that goes back, well, yeah, some of the problems we did yesterday, not the one we did because it was special. We're going to use trig to help us find the angles. And let's see how that works. Here's a pretty simple situation. It's a right triangle. I know 2 of the 3 sides. I don't have to do anything special really to find the third side. I just need to use my Pythagorean theorem, right? A little bit of work, but not too bad. Set a Pythagorean theorem for me in this picture. How would I set that up if this is going to be x down here? What's Pythagorean theorem going to look like set up? Yeah. And these are not terribly difficult numbers. Subtract the 81. So x squared is 43. So x is the square root of 43, which is not going to simplify, and that's fine. I've got all three sides, don't I? So I've got all three sides of that triangle. Now, I have to pick one angle to solve. Since I don't know either of those two acute angles, I need to choose one of them. It doesn't matter which one you choose. You just have to choose one. All right? Matt, you got something for me? Yeah, you do. I don't care who you're texting. Put it together. Hand it over. Come on. Come on. No. Come on. Sorry. Not during class. We'll talk about it at the end of class. Come on. I'm done playing games with the phones. You got it out and you're using it during class, it's going to be mine for a while. Don't do that. All right. So, pick an angle, A or B. I don't care which one. B. Okay, fine. We're going to go with B. There we go. So we got B. Now, which two sides, since I chose B, this side I just found is the square root of 43. I probably don't want to use that one. This is a danger number. In case I made a mistake, I prefer not to use that one. So I'm just going to kind of ignore that for now. But there are two sides I definitely know. With regard to this angle, 9 is which side? That's the opposite, and 12 is the hypotenuse. So what ratio do I know? Sine, cosine, or tangent for this? Sine. So I know that the sine of B is 9 over 12. Or, if I prefer, I could reduce that to a decimal of 0.7500. All right? What I need to know is what angle has that ratio for a sine. And the easiest way to do that is in the chart in the back of your book. So it's page 925. And I have also, so get out your book. Page 925. Now, when you get to page 925, what I want you to do is I want you to look at the column that says sine and see how close you can get to 0.7500. We've done this a little bit before. You may have to go over to the second row. You will, actually. Okay? And 0.7500 isn't directly in there, but I can kind of narrow it down. It's between what two angles? What do you find? Well, between 49 is 0.7547 and 50 is 0.76. Between 48 and 49, yeah. You're very close. Okay? This angle must be between 48 and 49 degrees. And 0.7500 might be just to the nearest degree is a little bit closer to the 49. So let's go with the 49 because it's closer. Okay? So I'm going to say this is about 49 degrees. Based on the fact that the sine of that, it has that value. That's called using an inverse function. It's a reverse lookup type of thing. And if this angle is 49, then this angle must be 41 degrees. And are we drawn to scales? No, apparently not. That's okay. Well, now we've solved that entire triangle, haven't we? Now, the other way of doing this, and we're going to do ours, like I said, pretty much with the lookup, because that's the most intuitive way for most people. But the other way of doing it is to use the sine inverse function, which is on our calculator. And if you want to do it that way, we can get the exact angle, and it's a second function sine. When we use second function sine or sine inverse when we're looking at an angle. Now, a lot of people get confused with this, and they're, well, wait a minute, when do you use sine, when do you use second function sine? If that is going to confuse you at all, then don't do this part. Just find the decimal and look it up in the table. Because I'll give you this table of values in the test. I'll give you a sheet with this table of values on it, so you can look stuff up if you need to, okay? But if you want to know how to do it in your calculator, you just put in second function sine, sine inverse of, and you put the ratio in or the decimal. You can actually put the ratio in, 9 divided by 12. And it's actually 48.6 degrees, closest to 49. Gives you the exact measurement now. So we can do it with a lookup in the chart, which most people will find easiest and is perfectly acceptable. Or we could use our calculator, remembering that we use the inverse function only when it's an angle that is the unknown. If we're looking for a side, we never use the inverse function. We only use an inverse function if the angle is the unknown. Now, how does that work mathematically? It's always a question people ask. Well, I know that the sine of my angle, which was B, I was going to write A, but it was B, sine of B equals 9 over 12, right? And an inverse function reverses the original function. So if I take the sine inverse of both sides of that equation, the inverse of a function, when you multiply a function by its inverse, they cancel out. And that's how we find the angle. So from an algebraic standpoint, if you're into the algebra portion of how this works, that's what's going on. That's a function that's inverse. Now, I don't think you spent a whole lot of time on inverse functions in Algebra 1, did you? You spend any time on inverse functions? No, okay. So that is more of an Algebra 2 type explanation then as to what's going on there, which is one of the reasons why people get very confused about it, because really that's something you haven't talked about much yet, is inverse functions. So if that inverse function thing, like I say, if that's just making your brain hurt right now, don't worry about it. We'll just look stuff up in our chart. We'll create the ratio, decimalize it, and see how close we can get in our chart. And that's an easy way of looking it up. And looking at a chart, you guys are pretty good at that. That's not intimidating at all. Find the number, trace it back. Just make sure you're in the right column. And don't be looking in the cosine column if you're looking for a sine. That's kind of important. All right. So again, this kind of talks more about using the sine inverse. Sine inverse is used when we don't know the angle. But like I said, I'm not requiring you to use a calculator for that. We can use our table for that. I think that'll just make life a little bit easier. So that's what I'm kind of switching up. So again, we only use sine inverse when we're looking for an angle measurement. But let's take a look at this. Two different situations here. And just looking at the pictures and deciding how we're going to approach them. In this picture, I know the right angle and another acute angle, which means my third angle can be easily found, can't it? I don't need anything fancy. I don't need to set up sines or cosines or anything. I know two angles of the triangle. I can find the third angle quickly because the angles add up to 180. If I know two, finding the third is simple, right? If this is 90 and this is 68, this better be what? 22. That's all it takes. And even easier, I can say in a right angle triangle, these two angles have to be complementary. They have to add up to 90. So I don't have to go to 180. I can just take 68 plus what is 90. That's all we have to do. Finding the sides would require trig. And the sides here would require trig. So to find this, the sides here, we'll use this angle because that's the one that's given. We can just set up sine of 68, cosine of 68, and tangent of 68. Now, don't just put sine of 68 equals and look it up in the table and the decimal down. Don't do that. Use the ratio value. Sine of 68 is opposite over hypotenuse, x over y. Cosine of 68 is adjacent over hypotenuse, 8 over y. Tangent of 68 is opposite over adjacent, x over 8. So this equation can't be solved, but these two can be. So from this one, we get y equals 8 over cosine 68. And here we get 8 times tan 68 equals x. So again, I just plug those numbers in my calculator. Boom, we're done. No problem. What the calculator is doing is it's putting in the decimal value for these when you do this portion. Okay? That's what the calculator is doing essentially. So if I have that acute angle measurement, I don't have to ever use the inverse functions or my tables at all. Here, I don't have either acute angle. So we're going to have to set something up. Now, before I can set something up to find the, finding the third side is Pythagorean theorem. 12 squared plus 15 squared is c squared. So 144 plus 225 is c squared. So that's 369. So c is the square root of 369. What goes in? What's the square root of 369? Does that come up perfectly? No, it doesn't. But we'll just leave it there for now. Okay. I know 9 is going to go into that. 41, 3 root 41 actually. If I wanted to reduce it. How do I know 9 went into it again? 3 plus 6 plus 9 is 18. 9 goes into 18, so 9 goes into 369. Okay. Find the angles. Well, pick an angle you want to find, A or B. We found B last time. Let's find A this time. Identify which sides I know. 12 is the opposite. 15 is the adjacent. Which function is opposite adjacent? Tangent. So tangent of angle A is 12 over 15, which I put that in my calculator. 12 divided by 15, that's 0.8. Well, if that's the tangent, let's look in a tangent column. 0.8000. That's really close to what angle? 30, careful as you're reading across. 8000 would be closest to 39, wouldn't it? Okay. So about 39 degrees. What did you get in your calculator? Okay. To the nearest degree, that would round up to 39, wouldn't it? Okay. And once we know this is 39, then this has to be 51 degrees because these have to add up to 90. And if you use your calculator, second function, tangent, 12 over 15, you got the exact answer by using your calculator. Either way. Just be very, very careful if you're using your calculator that you're not using it inappropriately. Some people do get very confused by that. That's my iPad. Don't worry about that. Let's try this one. I want to solve the triangle. The instruction is solve the triangle, which means find all the parts of it. I've got the right angle, but no other angles. So how can I find, what's going to be, well, what would you like to find? Tell me. I'm missing angle A, angle B, and side AB. Which would you like to start with? Side AB. All right. So we'll call that X for now. Pythagorean theorem, 10 squared plus 18 squared is X squared. Plus 324. So X squared is 424. So X is the square root of 424. Oof. Square root of 424. So is it 2 root 106? I don't think anything goes into 106, so that's probably it. But again, very important as you're working on this homework, and especially on the testing quiz, that you show all these steps. So if I see you got the square root of 4, x squared equals 424, I know you're going to get some points on this problem right away. You've already set something up and solved it correctly, even if you simplify it incorrectly. That's okay. Pick an angle you want to solve for, A or B? B, okay. So it'll be down here. Short body, long neck. Okay. As far as B goes, 10 is which side? And 18 is the, are we going to use the 2 root 106? No, because number one, it's messy. Number two, it's a calculated number and I made a mistake. Which function? Opposite adjacent? So tangent of B equals 10 over 18. Or 0.5556. So I put that, go to my tangent column, 0.5556, very close to 29 degrees. Which means to be about 61 degrees. And if we did in our calculator, second function tangent 10 divided by 18, 29.05 degrees. So pretty close. You see how this stuff works? It all starts coming together. I mean, we're really starting to see all the parts being there now. And it's, like I said, just fine to use the charts to look up the values and not rely on your calculator. Let me just give you a little hint. If you wind up doing something in your calculator for sine, cosine, tangent, and using the inverse, everything winds up being either like 0.9999 or 0.0012, you're probably not using it correctly. Just a little hint. How about here? What's going to be easy to find? Angle B, yeah, because I already know two angles. Angle B's got to be what? 20 degrees. So I'll call these other two sides X and Y. Now we're going to use our given angle as our angle, again to be safe. And we just start setting up our equations. Sine of 70, cosine of 70, and tangent of 70. Not all of them are going to work for us. We'll pick the ones that do once they're set up. Sine of 70 would be what ratio? X over 21, opposite over hypotenuse. Cosine of 70 would be Y over 21. Tangent is X over Y. That's not going to work for me, so we'll just not forget about that one. How do I solve? I'm not going to switch because it's in the numerator, so I'm going to multiply by 21 to cancel division by 21. And same here. So 21 sine of 70 equals X, 21 cosine of 70 equals Y. And 21 sine 70, 19.73 for X, 19.7, 21 cos 73, 7.2, the nearest tenth. Do the answers make sense? Yeah, they do. Everything works great. We can solve triangles now, can't we? If it's a right triangle, we can find all three sides and all three angles as long as we're given just a little bit of information. Now, I could run this thing through the exact same process, but I could also save myself some time if I'm observant. What do you notice about the relationship between the short side and the hypotenuse? Twice as long, so this side has to be 7 root 3, so this angle is going to be, okay, which one is this going to be? 60, and this is going to be 30. Do I have to use any trig? No, recognizing that pattern pays off sometimes. If I didn't recognize the pattern, could I come up with it? Sure. I mean, when you set up, you probably choose like angle Z, and it would be cosine of Z is 7 over 14, which is 0.5000. And 0.5000, it actually shows up in your cosine column perfectly at 60 degrees. There it is. So it would have worked out. It's not like it wouldn't work if we use a trig on it. It's just a lot faster if we recognize the pattern. So the trig still works. It's just not, you don't have to use Pythagorean theorem. It's much easier if you recognize the pattern. Okay. Actually made it through today. Wow. That hasn't happened in a while. So, okay. Come here. Come this way. There we go. So here we are. It's not a big assignment. 45, 3 through 12. 10 problems. It's not huge. One of the trickiest things is you just have to decide what to do each problem. And if you're just one of those people who's always very curious as to, well, what do we do if it's not a right triangle? You can read pages 490 and 491. They kind of talk about how we deal with oblique triangles. If you're curious about this sort of thing, you will not be tested on it. If we were honors, that'd be a topic we'd cover. So if you're curious about it, it's in there, and you can take a look and see how you work with oblique triangles, solving them. Well, that gets fun. In fact, we spend an entire chapter on that. We spend like 2.5 weeks on that in pre-calculus.